Alright, this is linear approximations, derivatives of absolute value functions and piecewise functions. Alright, so in the first part they're asking us to describe the tangent lines of each function. Alright, as above or below. So if I were to draw some tangent lines on this, notice that all the tangent lines will have to be below f of x. Okay. Now also what I can do, or what it's asking us to do, is to describe whether it's positive or negative. Notice that all the slopes on this tangent lines are negative. And then finally they're asking us if this is an increasing or decreasing rate. Notice that as you're coming from left to right, alright, the slopes are becoming, if you will, that's really negative, less negative, and even less negative. So they're becoming more positive. So I would say that this is decreasing at an increasing rate. Alright, on the next one, if I were to draw some tangent lines, they would still be below f of x. Right, however, on this one, the slopes are positive. And on this one, as I'm coming from left to right, alright, the slopes are becoming more and more positive. So therefore, this is also at an increasing rate. So I'm increasing at an increasing rate on this one. Right, on the next one, if I were to draw some tangent lines, alright, that would be above f of x. Okay, be above f of x. Notice that the slopes of these are positive. And from left to right, I'm increasing. But on this one, I'm increasing at a decreasing rate. I'm slowing down as I come from left to right. They're becoming more negative, if you will. The slopes are becoming a little bit more negative, or they're getting a little more flat, if you will. So I'm increasing at a decreasing rate. And on here, okay, if you have the tangent lines would still be above f of x. And on this, because you still have negative slopes here. And on this one, because you're coming from left to right, you're decreasing. But as you come from left to right, these slopes are becoming more and more negative. So this one's actually decreasing at a decreasing rate, because from left to right, the slopes of the tangent lines are becoming more and more negative. Alright, so now I hope you listened to that video, or you looked at that video that I sent to you earlier. I think that he does a better job of explaining what I'm about to explain here. So on this right here, what linear approximation is, what this says basically is if you have a curve and I'm trying to find, alright, what I'm trying to find is the value of this point right here, which would be f of x. Right, if I'm trying to find out what f of x is, alright, but assuming that I don't have a calculator, or I'm in the 17th century and I don't have a calculator, what I can do is I can find a tangent line, alright, and that tangent line would have to be pretty close, alright, the point on the tangent line, the point that touches the curve would have to be really close to, this point. So x and c would have to be really close, okay? Now, what that says, what linear approximation says, is if I can figure out the equation of this tangent line, alright, if I find the equation of this tangent line, and if I were trying to guess what f of x, what the y coordinate of this, what that says is that this point right here on the line and this point right here on the curve are so close that you can say that one of them is almost equal to the other. So they're approximately the same value. That's what they mean. So right here when they write this, that f of x is approximately, notice that all of this is just the equation of the line. Alright, so this is just the equation of the line, and you would plug in that x value into here, and you would get the y value. And that y value, that it is up here, is close enough to this one that we can say it's approximately the same value. Alright. So I know that sounded really complicated, so let's do a problem, and hopefully that'll clear things up for you. Right, on example 1, they're asking us to use linear approximation to find the value of f of 2.97. So the first thing I need to do, all right, so remember, since we're doing linear approximation, is I need to figure out a tangent line. I need to figure out the equation of a tangent line, all right, to f of x. So the first thing I have to do, since I don't want to use the product rule, is I'm going to go ahead and distribute this. So I would have f of x is equal to 4x cubed plus x squared. All right. And now to find the equation of a tangent line, I need to find the slope. Okay. So the slope would be 12x squared plus 2x. All right. And now in this one, I have to choose a point. I'm not going to choose 2.97 because this kind of thing makes it difficult, right? So instead of choosing that point right here, I'm going to choose a point that's really close to that. So I'm going to choose a point that's really close to 2.97. In this case, I'm going to choose 3. So when I choose 3, so again, just choose a point that's close. All right, so this would be the a value. All right, so this would be, this is the a value. Okay, so this is the a value that you see in this formula, basically. Okay, so I'm going to choose 3, and then now I'm going to find the equation of the line. All right, so remember, to find the equation of the line, what you need to do is figure out the y coordinate. So I'm going to need to figure out the y coordinate of this. So I'm going to go with f of 3. I'm going to plug that into here and figure out what the y coordinate is. So we got 3 cubed plus 3 square, and that turns out to be negative 117. I mean, if you have to use a calculator, use it, it's fine for this this simple arithmetic, if you will. And then now, so remember, this is my y coordinate. All right, so I'm just going to write here y coordinate. So I have a point. The point is 3 and 117. I need to figure out my slope. All right, I have to figure out my slope at 3. So I'm going to use that derivative, and I'm going to plug in that 3. And whatever number comes out of here, that's going to be the slope of the tangent line at x is equal to 3. Okay, plus 2 times 3. That's going to give me 114. And again, this is the slope of the tangent line at x is equal to 3. Right? So now, I'm going to build the equation of the line, which we know is y minus 117 is equal to 114 x minus 3, like that. So that's the equation of the line. And then now what I'm going to do, and I guess what I'm going to do from now is I'm going to add that 117 to that side. So I'll have something that looks like an equation. Now, if you're going to ask me, well, could I distribute that 114 and then add like terms? The answer is yes, you can, all right? But I think it would be easier if you leave it like that, okay? Just FYI. So this is this right here with the linear approximation, all right? So this is the linear approximation. So we're going to still try to find the value of 2.97. So the thing that we do next, all right, so I'm going to write it up here. So I'm going to come over here now. And so again, all that I found was the equation. So now to figure out the linear approximation, all right, what I'm going to have to do is I'm going to plug in 2.97 for x. So again, if you had this f of x, so notice I'm calling this f of x now. F of x is approximately 114 x minus 3 plus 117. Now, I know f of x is not this. See, f of x is right here. But what I'm saying is that f of x, the value of f of x close to 2.97 is approximately this. All right, so basically I'm saying that this line at this point right here, they're approximately the same height, if you will. All right, so all I'm going to do for now is I'm going to plug in at 2.97 and then try to figure out what that's going to be equal to. So I'm going to evaluate after this. Again, use your calculator. That would be approximately 113.58. Alright, so again, this graph doesn't look like this, but what I'm saying is that if you were to plug in 2.97 into this equation right here, you would get approximately that. Alright, so the last thing it's going to ask us here is going to ask us if this is, if the approximation is too high or too low, and that really depends on the tangent line. Alright, so this is what I mean. So what you have to do is you have to sketch this. Now, assuming you're sketching this without a calculator, alright, what I would do is I would come over here and I would try to find the roots here. So I would say find roots. Now, if I were to find the roots, here I apparently have a double. And if I have this one right here, I have x is equal to negative 1/4. Okay, so let's say that this is, 1. So maybe a fourth. Let's call this a fourth here. Right, and I have that right there. Okay, so I was going to cut it really close. But anyway, my point is, notice that this is degree 3, right? If you were to multiply all this, well, you can see it here. This is degree 3 and it's positive. So, and I have a double root right here. So it should look something like this. Okay, something like that. Now, because of that, all right, 2.97. Let's say that 2.97 is over here somewhere. 2.97 is right here. Is that point right here? Now, or sorry, this is 3. So let's say that 3 is right here. Okay. So my approximation. This line right here is this line that I got right here. That's the equation of that line. Alright, and the value that I got was right here somewhere. Now, only because the tangent line is below the function f of x, then that means that my approximation is going to be too low because my tangent line that I drew is below f of x. Alright, so in this one, I would say that it's too low. My approximation is too low because the tangent line is below the curve at x is equal to 2.97. Okay? Now, obviously on this one you can probably use the calculator to make it a lot easier, but so you probably won't see something quite like this on an AP exam. This is just to explain the method. But what you may see instead is more of a question like, like example 2. Alright, so it says suppose the only information we have about the function is that f of 4 is negative 2. So remember, this is the point. So I have a point 4, negative 2. And the graph of its derivative is shown below, right? So we have this is a function of the derivative. So don't forget, this right here is the derivative. This is not f of x, alright? And it says use linear approximation to estimate f of 3.9, okay? And is your estimate too high or too low? So here's what we have to do. We have to find the equation of the line, all right, and we're going to have to find the equation of the tangent line, specifically at x is equal to 4, only because that's pretty close, all right? So again, we're going to choose x is equal to 4, and this is the a value. Alright, and again, I'm just telling you that's the a value so you can look at this formula and you'll be able to tell what exactly I'm going to do. Right, so I'm going to find the equation of the tangent line. So notice that I chose a to be 4. So now to figure out the equation of a tangent line, what I have to do as before is I need a point and I need a slope. Notice that I already have the point. The point was f of 4 is equal to negative 2. Alright, so meaning that point is going to be 4, negative 2. So I already have the point. So now I need to figure out the slope. Alright, so I need to figure out the slope at 4. Right, I need to find the derivative at 4, and that will give me my slope. Now, when you look at it, you don't have an equation here, right? You don't have an equation to figure that out. So what you do instead, since this is the derivative function, you have to go to 4. 1, 2, 3, 4. And then this y coordinate, all right, this is 4, 2, 3, 4, 5, 6. This is 6. This right here, that right there is, this is f of negative 4. Excuse me, this is f prime of 4. So this is the slope. So the slope is 6, all right? So remember, every y value on here represents the slope on f of x. So the slope on this one would be 6. And then now I need to figure out the equation of the line. So I would have y plus 2. Notice that I have a minus and negative, makes it a positive. Is equal to the slope times x minus 4. Okay? Now as before, what I need to do, notice that that's the equation of the line, so it shouldn't be too hard. You've done this before. What I do from there is I go ahead and add that f of a to that side. So I'm going to add this, so in this case I'm going to subtract this 2 from both sides. And I end up with y is equal to 6 x minus 4 minus 2. Okay? Now, what we're saying, yet again, is that, I'm going to come over here. I'm saying that f of x, whatever that function may be, is approximately 6x minus 4 minus 2. Right, so at that point, when it's really close at least, that tangent line is approximately that value when I'm close to 3.9. All right, so now I'm going to plug in that 3.9. And really, you could do this, if you wanted to, you could do this by hand. It wouldn't be that hard. You know, that'd be negative 0.1 times 6. It'd be negative. It'd be negative 0.6 minus 2 would be negative 2.6. So f of 3.9 would be approximately negative 2.6. Right, now they're asking us if the approximation is too high or too low. And to be able to tell that, what you have to do is, one more time, you need to sketch this graph, or whatever you think this is. Notice that I have maximum, excuse me, this is a minimum and this is a maximum. Okay, so if I do some sign analysis real fast, I have maybe negative 1 here and 6.5. This would be minus, plus, minus. This is the derivative. So f of x would be decreasing, increasing, decreasing. Alright, so what that would look like, let's make sure here at negative 1 and at 6.5, I have to have a minimum right through here. I have to have a maximum. And that's probably what it looks like. Now, 3.9 would be somewhere around here. Alright, so if it's 3.9, and that would be kind of the weird part, 3.9 would be above. So if the tangent line is above, then this approximation is too high. Right, so approximation because the tangent line is above f of x. I'm running out of room here, I'm sorry. Okay, so I know if you don't understand this, make sure and rewind that and ask me questions tomorrow. This is kind of a hard concept to understand at first, right? So the next few are relatively easy. If I'm going to try to take the derivative of a piecewise function, what I do is I'm going to take the derivative of this, and I'm going to take the derivative of that. So f prime of x is equal to, so I have another piecewise for my derivative. This will be negative 2 if x is greater than 1. And this one would be 2x, so the derivative of x squared is 2x if x is greater than or equal to 1. Right, so that's that for that one. So again, just take the derivative of both functions in here. Right, for the next one, if I have an absolute value, right, I have to split that up. So this is actually f of x, and I've kind of talked about this in the past. this equation can be broken down into a piecewise function by saying that x, all right, we have a function, a linear function, x, if x is greater than or equal to 0, or negative x if x is less than 0. All right, so this would be the negative, that's the positive. So when I take the derivative, right, the derivative of x is 1 for x is greater than 0, and the derivative of this one would be negative 1 if x is less than 0, and that's it, right? So you just have to break them apart. So for example, one that's more complicated, example 5, what you do here, you break this one down. Now you do have to figure out, for example, you have to set that inside equal to 0 to figure out where the 2 points meet, and it turns out that this is, excuse me, running a little bit late. So that would be this right here. And normally I make this right side the positive side. Definitely though, when you take the derivative though, you want to leave this inequalities without the equal sign, alright? So the derivative of that is 2, the derivative of this one would be negative 2. This one is if x is greater than 1/2, negative 1/2, excuse me. And this would be if x is less than negative 1/2, okay? Alright guys, that is all. I'm sure you're going to have questions, so make sure and ask me when you see me either tomorrow or Monday.